after I talk, Robert is going to talk about sciencey stuff, which I think will be good until he stands up. And then Peter is going to talk about how our rational brain works. But just to weirdly introduce myself, my name is Maeve, I'm an architect, and these are the slides from the Petrocucha Nerd Night I did when I lived in Phnom Penh in 2010. So that event that I used to go to there kind of inspired this event here, so I thought it was apt to do the same presentation. So, in 2010 I randomly went to live in Phnom Penh and found a research project that was affiliated with Yale that was researching the work of this guy, Vann Molyvann. There he is as a young man in front of a Cambodian temple. And the basis of the project was, his buildings were amazing, they were built in the 50s, but then say the Khmer Rouge happened in the 70s and the country was basically decimated. It was one of the worst genocides of all time. So the country now is rebuilding itself, but there's a lot of corruption. Developers are buying the land underneath the buildings and tearing them down or setting them on fire and stuff like that. So the project I worked for was about documenting them because they're so fascinating and there's such a wealth of knowledge for the rest of the whole world. So the process we used was literally climbing around buildings with measuring tapes. I flew to Phnom Penh the morning after a full moon party in Thailand, and the next morning I was hanging off a building in April with a plumb line to measure the height of it, so it was definitely hands-on. And this was the end result of that research project, an exhibition in the French Centre and a body of drawings that are in the Yale Research Library. So, as you can see, there's photographs on the right there of Vann Mollyvann's own records, and then we made models of the buildings as well. So his architecture is passively designed. So that means that you put like tricks into a building that don't cost any money, but make it function better. So it was also climatic design, so it was designed for the area itself, which is hot in Cambodia. It's not like you wouldn't design like that here. So what needs to be considered for climatic design is climate, the comforts of the people inside the building, the sun from both heat and light perspective, wind, because you can channel that and control it to create air conditioning, and the materials that you use. So Phnom Penh is in fact a hydraulic city, which means it's actually a basis of canals. So there's two rivers which meet, the Tonle Sap and the Mekong. There's an enormous lake which has been filled in by developers, like tons of sand. They're building apartments on it. And there's a whole network of canals which actually don't work because they're blocked and they don't have the infrastructure to unblock them. Imagine how stinky that is. One of the things Vann Molyvann did was say, right, in Cambodia we have this climate, it's hot, it rains a lot. So instead of trying to hide that, he celebrated it. So these are sunshades and scuppers to catch rain. So he just made a really big gesture out of these points. He also used a lot of water. Water creates a microclimate where it absorbs heat and cools down the area around it, which is a really useful thing to do in a hot country. It also creates a sense of place where people gather. The other things he considered was comfort and this idea of collective memory. So collective memory is where you keep things in the design of cities or towns that your parents remembered, your granny remembered, like their grandparents remembered, like iconography or like large cathedrals, like that will connect a community together and keep them stronger and just generally make it work better. From the sun, he brought it in from all sorts of different directions. You can see in the photograph, it's indirect from the top, and then indirect in a different way from these scuppered walls that he created. So it creates this dappled light effect. In this photograph, that wall, the way it deals with the sun, changes from top to bottom because the sun is higher and stronger. So he filtered it at its highest point, but let it in the low evening light. This is a theatre which was set on fire and destroyed. So when they needed the lights, they let it in the evenings and protected it from when it was too hot. These are the lectures of the Institute of Foreign Languages, and the louvers on the lecture walls are orientated in different ways to bounce the east light or the west light into the room. So inside that room the light was really soft, but it was amplified in a way, so it's completely natural. You don't need to turn on the electricity, and you didn't need aircon, because you can see here there's a double roof which creates a shadow, so it cools the building down. The air is sucked in with these scuppers from the top and filtered through, and it's also breathing from side to side as well, so east-westerly winds are channeled into the buildings. So it's all well and good to kind of research that and go, yeah, it's climatic, it's passive. But when I went into this house in Cambodia, I had to put a scarf on. It was actually cold, like in the tropics, in the middle of the day. So I really kind of started to become a convert then. This is the National Stadium, and you can see all the lights. So down underneath your seats, there's nothing there. The seats are all suspended, so there's going to be a cool breeze coming in underneath at your ankles, which is going to cool down your whole body. So for that whole, it was an Olympic-sized basketball arena. There was no mechanical aircon. The stack effect is quite a common trick. It's a chimney effect that designers use to create airflow throughout a building. You see it used in buildings here where they have like a kind of a chimney, but here he was like, just put loads of chimneys all over the roof and make it work really well, and it did. So air would be sucked in from below and drawn up through the building and cool the whole thing down. You can see there's overhanging areas at the bottom, so it's going to be in shade, so the hot sun is cooled and brought up through the building, and it genuinely worked. He was for a period of time working for the king. For 10 years they built 100 buildings, and they really wanted to make it work for Cambodia, so they chose materials that they could manufacture themselves, so they cut down on all the transportation costs as well. It's hard to see in the lights here, but the structure is tapering at this point here. So they were really applying the amount of concrete they were using. They just worked really well with engineers and didn't use any extra materials. And that's the presentation, that's the research. So this is like, I would kill anyone else who did this, like the presentation, but there's a petition to save one of the buildings because it's going to be torn down. I'm going to put it on the Twitter feed. Sign a petition, save Cambodia. It's not a platform for petitions. Our next speaker is Robert.